Thank you. I'm happy to be here. First time at the CSS Café. And I'm going to talk today about sharing styles with web components and Shadow DOM, between Shadow DOM and other shadow trees, between shadow roots and the web page. And this is all going to be, I'm afraid, kind of boring. But let me tell you. Let me quickly share my screen like this. And then we can dive right into the heart of the matter. Okay. Um, Now, you've heard everything that's important about me, except for the fact that as a freelance trainer and coach and consultant for web technology, you can actually hire me to come to your company and talk about basically everything related to front-end development, with the exception of frameworks. I don't care about frameworks, about Angular, about React. Everything but this is my game. Web standards, JavaScript, HTML, CSS not so much, but rather everything revolving around CSS. And in this case, today, specifically, how CSS interacts with web components. So what I have in store for you today is an extremely dry, extremely boring, uninteresting comparison between different approaches to sharing styles between different web components and your main page. And this is really dry and boring because it's really just a comparison. I'm going to list how different approaches to manage CSS and web components, and I'm going to tell you what the main advantages and disadvantages of each approach are. So first, we're going to take a little tour and take a look at Shadow DOM again, just as a refresher, so that we are all on the same page. And then it's all about sharing styles and different techniques for dealing with CSS and Shadow DOM. This is all kind of high level, independent of frameworks or specific techniques. We are going to talk about some aspects of performance, some aspects of memory, some aspects of impact that different approaches might have on your CSS architecture, as far as I can tell. As I said, CSS itself is not my strong suit, but again, everything surrounding it. And in the end, there's a giant boring table that we can use to compare the different approaches. And I guess there's then also quite a bit of discussion necessary to really hammer home how different approaches might work under different circumstances, depending on what you try to do. So let me just waffle on a bit about the different techniques and about Shadow DOM in general, and there's time at the end to talk about your questions and your challenges when dealing with Shadow DOM. Okay, but first, let's talk about Shadow DOM. What actually is Shadow DOM, and what is it really good for? Well, I think it's mostly meant to be used in conjunction with web components. Okay, now we need to talk about web components real quick, but only real quick in a high-level overview. The general idea behind web components is that you, as a web developer, can define your own HTML elements. You simply write a class in JavaScript, have it extend the native HTML element, which isn't exactly a JavaScript class, but kind of behaves like it was a JavaScript class. You simply write the boilerplate, stop thinking about the details, implement your functionality in terms of methods on the class, and then you basically just tell the browser to associate an HTML tag, in this case hello-world, with the JavaScript class, and then you're done. You can simply use this HTML tag now, and if you have instances of this element in your HTML, for example, or if you create new instances using document create element or something similar, you can call the method foo on your instances and get back the number 42. And that's your web component. That's probably not very exciting. That's probably not what you want as a web component. You want probably, I guess, some sort of user interface. And if you need a user interface for your components, then simply adding JavaScript methods that return some numbers won't really do it. We need something else, and what we need, many people say, is Shadow DOM. Shadow DOM is essentially what's used by browsers themselves to implement user interfaces on built-in elements. Let's take this wonderful input type date, for example. If you open the date picker, many of you will be aware, you get, a date picker. And in most browsers nowadays, this is implemented using HTML and CSS under the hood. There's a tiny little basically sub-DOM tree living inside of this input element that gets activated when you focus it like in this case, and you get back a date picker that's again implemented using just something that looks kind of like a button, that looks kind of like a table. This entire user interface is what we think of as Shadow DOM. And this is generally the main idea, the main use case for Shadow DOM, implementing the user interface for components, and the components then serve as an abstraction over this nested DOM tree. And the way to think about it is really of a sort of kind of insulated sub-tree in your main web page, a tiny little DOM tree that you hook into your main page, and that is in some ways more or less insulated from the effects of JavaScript and CSS that happen in the main document. And the other way around works as well. If you have some CSS and some JavaScript going on inside your shadow root, there's a high possibility that whatever you do in there won't affect the main page. But there's of course ways to work around this. There's of course ways to have the main page influence the shadow root under some circumstances. And there's of course always the possibility that you mess up your component in a way that influences the main page outside of the component, which is probably not something you want to do, but this is something that you can do or that can happen to you depending on what you do. The important bit about Shadow DOM really is that it's a bunch of compromises that probably won't fit your needs exactly, because it needs to do a whole bunch of different things. And one of the compromises is how style insulation works. And this is best demonstrated using some JavaScript. So let's create a shadow root real quick. For this, you need an element that serves as a host for the shadow root. Basically, you need an element that then contains not only its regular content, but also the tree that you nest inside of there. This could be a web component, but this can also be just a regular old HTML element like this div that I'm now selecting from the page. So this is my host element, and I simply append some regular text content to the element. Because this is right now just a regular element that contains a regular text node containing the text regular content, this regular content, is now what's visible, and this is just a regular text node that's a child of the main document. Okay, this works like expected. There's nothing special about this going on until now. But now we call the method attach shadow on the host element. There's a whole bunch of options that you can and sometimes need to specify, like the mode open. We are going to ignore this for now. This is not really important. The important bit is that your host element is now hosting a shadow tree, and because it does this job now, it's now hosting the shadow tree, the regular content has become invisible. The regular content is still there in the DOM tree, it still exists in the page, it's just not being rendered. Instead, the shadow tree is being rendered. You could think about this like the shadow tree being rendered on top of the regular content. This shadow tree, the object shadow here in line 4, is now just a regular node. It's kind of like an HTML element, which means that you can use all sorts of DOM manipulation methods on the shadow element. You can set the inner HTML, or you can append a text node to the shadow root. And now this text shadow content is visible and regular content is not visible. Regular content turned invisible the moment we attached the shadow root to the host element. But now the shadow root contains some content, this content being the text shadow content. This is now what's visible, and regular content is invisible. The regular content is in what's called the light DOM, the regular DOM, the not shadow DOM. And shadow content is a child element of the shadow tree that's hosted by the div element. So the shadow content is what's visible right now. Now, if you wanted to have both, if you wanted to have the regular content and the shadow content in the shadow tree, then you can use the slot element. The slot element exists specifically for this use case, for the use case that you want to have an element host a shadow tree, have the element render some content that's specific to the shadow tree, the text shadow content in this example, but you also want to project the light DOM that's being hidden by the shadow tree back into the shadow DOM. That's what slot elements are for. You can do a whole bunch of stuff with the slot element. You can have multiple slots element with different names and assign content specific to specific slots. This can all get quite complicated, but the important bit is you can have elements that host shadow trees. Shadow trees hide the light DOM that they are rendered on top of, and you can project light DOM back into the shadow tree by using slot elements. This is basically everything that you need to know about shadow DOM. It's really just DOM trees with some interesting properties that you can attach to certain elements. The important bit is that these are really special subtrees in your DOM because they have some sort of bunch of compromises for insulation purposes that we are going to talk about very soon. Its primary use case, the primary use case for Shadow DOM, is to contain really UI implementation details for web component UIs. You can use Shadow DOM for other purposes. Shep told me that he sometimes uses Shadow DOM to achieve some sort of performance magic that I didn't quite get, so ask him about details, but the main use case really relates to web components. And the notable features that make Shadow DOM a kind of good fit for components is that they feature some DOM encapsulation because you host your content in specific subtrees that are not readily accessible from the main page. There's event encapsulation going on, at least depending on how the shadow tree is configured and how the events work. And there's also style encapsulation at work. And this is really the important bit for today. Remember, everything in there is just a bunch of trade-offs, and it's all incomplete encapsulation boundaries, but probably maybe the encapsulation boundaries are set up in just such a way that they work for us. Maybe, maybe not. Let's see how they work. So let's get back again to our example. There's my host. My host element hosts some regular content. Again, this is just light DOM content. There's no shadow tree involved. But of course, I can now add some shadow tree. And just to make my life a little bit easier, let's assume that this element function exists that simply creates an element and adds contents to the element and then returns the element so that I can simply have a one-liner to create an element and also set its inner HTML, just for convenience sake. Okay, so let's create some content, shall we? So let's take our regular content, shove it into a p element, and append the p element to the host. Again, this is light DOM. There's no shadow tree involved, so this is going to be visible. This is going to be part of the regular light DOM. This is just going to be an everyday boring p element. And if we then attach some CSS to our web page, in this case by creating a style element and adding a rule that turns all p elements red, then of course this style is going to affect the p element that we just added to our host element. Line 10 results in the text regular content being rendered in red. This makes sense. Now of course let's add our shadow tree and let's add our shadow content in a p element to the shadow tree. Now this is both p elements with some text in them, but the important bit is that the style rule that turns all p elements red is contained in the main page on the document body, and the text shadow content is contained in a p element in the shadow root. And as such, it's insulated from the effects of CSS in the main document, at least as far as selectors go. The selector p does not match the second p element in the shadow tree because it's in a shadow tree and the selector doesn't apply. So the p element shadow content is going to be visible and it gets rendered in the default color. The text regular content that's part of the light DOM would appear as red text if it was visible, but it's not because the host element also hosts a shadow content. So we are essentially layering DOM trees on top of each other and having our CSS apply to different p elements in our structure. Now, what we could do is, of course, take the light DOM p regular content and project it back into our shadow DOM using a slot element that I've just added now in line 15. Now the p element regular content becomes visible as a child element in our shadow tree, but because it originates from the regular content and not from the shadow tree, this thing is actually going to be red, and as it's now rendered into the shadow tree via the slot element, it's going to be visible. So this is quite confusing if you just look at it with your eyes when it's getting rendered, because there's two p element. They look exactly the same because they live on the same page. They inherit the same basic font style, but one is red, one is not, because one lives in the shadow tree and does not get targeted by the style that we defined in line 7. What we could then, of course, do is add some style to the shadow tree. Why not? This new style rule in line 15 now again targets all p elements and turns them blue. But of course, because the style element now lives in the shadow tree, it only targets elements that live in the same shadow tree. So our shadow content is now blue and visible, and our regular content is visible and red. It's visible because it's being projected in the shadow DOM using the slot element, and it's red because the style rule from line 7 applies to it, and the style rule from line 15 does not. So this is all possibly confusing, possibly not. The important bit really is that it's all about CSS selectors. CSS selectors only apply to elements within the same shadow tree or light DOM tree. They do not penetrate this encapsulation boundary. What does penetrate the encapsulation boundary is actually general styles. Stuff still gets inherited, just selectors don't penetrate the boundary. So if you do something like assign font weight bold to the host element, to the div element, then this is just a font style that gets inherited, or it's a font weight to be precise, that gets inherited, and this inheritance applies to the regular content p element in the light DOM as well as to the shadow host. So one element is going to turn out red and bold. Red because the rule matches the p element in the light DOM, and bold because it inherits the style from the host element. And for the shadow content, it turns blue because the style rule for p color blue applies to it, because they both share the same root, the same shadow root. But it's also going to turn out blue because bold because this style gets inherited. So, and this is basically how CSS affects our CSS in a nutshell. Of course, there's more complications. There's selectors that you can write to select elements that get projected into slots, and there's many more details, but in general, for your everyday CSS, that's just regular selectors and regular style elements that you simply load into pages or into shadow roots. This is essentially how it works. So, to summarize, CSS does not leak out of a shadow root in any way. Something that happens in a shadow root stays in the shadow root in general. Selectors do not apply to elements inside other shadow roots, or if you're talking about the main page, if you're talking about the light DOM, selectors defined in the light DOM don't apply to shadow roots. Again, unless you perform specific magic steps that are out of scope for today. And the third thing is that apparent elements inherited properties get inherited to shadow DOM. This is mostly relevant for CSS custom properties, for CSS variables that you can use to do something like create an overall theme for your web page and inherit it down into your components, into your shadow root. So, as you can see, it's not exactly super isolated what you do in your shadow DOM. It's kind of isolated, it's reasonably insulated, but it's not a total insulation boundary. If you want complete encapsulation, you should probably use an iframe or something. But for a kind of mixture of different trade-offs for your CSS insulation, this is how Shadow DOM does it. Okay. Again, there's a whole bunch of complications and special selectors and so on that we're not going to talk about today. This is how it works in general. And this is kind of nice if you just take it as read, because, hey, you can create your web component and you can use your web component and you can be sure that if you write some CSS in there, that it will only apply to the shadow root. Or you could also create some styles and load them into your web page and have these styles, your main CSS, only apply to the main web page, and you won't have it interfere with whatever's going on in your custom element. Which is great, if that's what you want. And you might think you want this, but you probably don't. Because I guess in your main CSS, there's going to be some things that are not simply inherited properties that you still want to use in your custom elements, or at least there's some bits that you will want to use. So this might look reasonable on the surface because everything is segregated, everything is isolated, everything only applies to where it's written, but still, maybe there's some classes in main CSS that you want to reuse in your web component. Well, if that's what you want, then you're out of luck, because selectors do not penetrate the insulation boundary. If you want to use inheritance, well, it works for CSS variables, and that's good, but is it enough, or do you need more than this? If you need more, then again, you are out of luck. And most importantly, if you have more than one custom element and you want to share some styles between components, then again, you are out of luck, because every element has its own little shadow root, and those shadow roots don't talk to each other. at least in general. And this makes sense at a glance, but still, this is rather limited if you're trying to do anything that's even remotely complicated. And so this begs the question, how can we take the compromises that Shadow DOM comes with and still make our different components and the web page share some CSS in a controlled way? How can we work inside the limitations of Shadow DOM to make our projects work and not simply have us repeat our CSS over and over again? So this is what we're going to talk about. Shadow DOM separates the styles between our components and between our web page, and how can we open specific doors to let some CSS leak through. Okay, now comes the boring part, comparison of techniques. And the most boring technique that I can offer for this is, Shadow DOM is something that you can use, but you don't have to. You can simply skip Shadow DOM, because this is the easiest way to fix any problems associated with Shadow DOM. I mean, if we think about software engineering, what does engineering really mean? Engineering means dealing with problems, but engineering doesn't mean that you need to engineer solutions around a problem. Sometimes engineering can also mean that you eliminate a problem. The best fix for any given problem is to remove the source of the problem when that's possible. This is not always possible, but if you can simply, remove something dangerous, then you do not need to engineer some sort of guardrail against something dangerous. And if you can create your components without using Shadow DOM, then probably not using Shadow DOM makes your life much easier. So the proper way to do web components, of course, is to create a shadow root and is to attach your HTML to the shadow root, but then you have all the associated problems with CSS. But you might just get away with not using Shadow DOM. I'm just saying, this should be an option. This should be on the table. And the fact that this isn't the most crazy idea, you can see this if you take a look at all the legacy front-end frameworks. If you take a look at, I don't know, React, Angular, what have you, these guys also use components and they don't use Shadow DOM, and they, work fine. I think for everything that you can say about React or Angular or the general state of modern web development with regards to performance and having to do npm update every 2 minutes, it still kind of works, right? And it works without Shadow DOM. So this should be proof enough that it's possible to create a reasonable web application without using Shadow DOM. So this is always a choice. It's reasonably useful for most components because, encapsulation and stuff is all fine and good. But, maybe the trade-off isn't worth it in some cases. And maybe there's some components where Shadow DOM is actually actively harmful. I mean, one web component that I wrote for myself that I get a lot of mileage out of is HTML import, which is really extremely primitive. It's simply a custom element that points to an HTML page and that takes an optional selector. And what this does under the hood is essentially request this HTML page, select the elements that match the selector, and then clone the nodes into the web page and simply dumps it as child elements into the light DOM of this component. So I can kind of use this as a client-side importing mechanism, kind of like HTML modules, sort of. This, of course, has performance implications, let's just say, but depending on your use case, this might be reasonably enough. I use this for my presentations if I want to create a new a new workshop about something, and I simply want to assemble some HTML modules. Then I simply import this from there, and then dump it into my presentation. That's a slide deck. If the slide deck takes a minute to load, no one's gonna care. It's still more efficient than a giant PDF page, and it can contain a bunch of JavaScript, a bunch of CSS. It's fine. In this case, style encapsulation would be a real bug and not a feature, because it would prevent me from simply taking HTML modules from somewhere and dumping them into my web page. Now, this is not your regular web component. This is not something that you will write a whole bunch of, but I get a lot of mileage out of this, and Shadow DOM simply is a problem that I'm not dealing with in this case. So you probably can get by without using Shadow DOM, at least for some components, and maybe even for the entire problem that you're trying to fix. I mean, this is the CSS Café. I guess that most of you have an idea of how you can write proper CSS. But let me tell you, out there in the wild, there's companies, there's people who have to create web applications and they don't have the faintest clue about CSS. And so how Shadow DOM and web components are then pitched to them is that they can use style encapsulation to solve all of their problems. Their problem mainly being that they don't know how to create a CSS architecture and them simply appending new rules to the ever-growing main CSS file. Now, this kind of works because this kind of works as a divide and conquer approach to CSS. I mean, you can encapsulate and separate different things, but one thing that should be obvious to you, but it's not obvious to everyone, is that you can also just write better CSS. Just for completeness sake, you can write proper CSS. You know this, no? But I was at a conference just yesterday where I did this talk for a bunch of PHP developers, and they actually needed to be told that this is not the only way to do it. This doesn't solve your problem. This is bad, but that you can actually use better and proper CSS. You can think about how you write your selectors, or you could even use fancy CSS features like scoped styles, for example. And you can even take your style tag, shove it into your component, and simply have it work implicitly without scoping it to a specific parent class. There's options to writing proper CSS. Again, you know this, not everyone does, and everyone who gets pitched web components and Shadow DOM as a solution for their CSS problems should probably try to fix their CSS problems first, and then throw a bunch of JavaScript at the problem as a second step if the first doesn't fix it. So this is just, the obvious point. You can skip Shadow DOM. There's also, of course, downsides associated with this because you might want to use some of the benefits of Shadow DOM, like encapsulation for not just CSS, but also maybe for JavaScript. And of course, you need to be able, you need to have the capacity, you need to have the knowledge how to write proper CSS. I mean, you're kind of also leaving maybe some performance benefits on the table if you skip Shadow DOM, because there might be some slight performance boosts if you use Shadow DOM. I think this is all a very slight advantage that you get out of this, so maybe this is not so important. And of course, as I said already, you need to have properly engineered CSS for not using Shadow DOM being an option in the first place. So maybe this isn't for you, but this should definitely be an option that is on the table. Web components do not equal Shadow DOM, and you can have web components without Shadow DOM. And maybe you don't even need web components. Who am I to say? So let's just keep this option on the table. Simply not having Shadow DOM resolves all the problems associated with sharing styles. Okay. Option number 2, or rather number 1, if we say that skipping Shadow DOM is option 0. The next option is to be as cheap and as simple as possible and simply dump your CSS inline into Shadow DOM. And this again sounds kind of primitive, but actually works quite well. Let's say this again is our component with a shadow root and some content in there. And the easiest, simplest way to put some CSS in there is to simply put some CSS in there, like this. There's nothing wrong with this. This looks barbaric, this looks like an Hello World example, but this is actually fine. You can do this, this will work. This has, of course, some downsides, but if you're looking for the simplest solution for sharing styles between web components, then simply sharing the code that generates the styles is an option. So this is fine, I'm going to argue, because it looks bad, but it works in a really obvious way. Anyone can understand this, anyone can debug this, anyone can extend this. No one needs to read any documentation. It's just using Shadow DOM as advertised. There's no engineering involved. You simply write styles into your code and then you're done with it. And you can use anything you want. You can use style elements, you can use link elements, you can use CSS features like imports and layers and so on, and simply go all in. And if you think that your developers won't accept this sort of API, you can simply dress it up a little to meet developer experience expectations. So this is quite of a reasonable way to do it for certain types of components, I'm going to argue. The main advantage is that this does not come with any dependencies, without any engineering. The most I would say that you can do to dress this up is maybe create a base class, because, let's face it, this doesn't look great, right? You have your HTML template kind of in the string, hello world, and then comes the style tag. Maybe this should be separated just for, general developer experience. Well, doing this is actually quite simple. You can simply create some sort of base class. You don't need to extend HTML element directly. You can have a base class and simply do some good old-fashioned object-oriented programming and simply provide a better developer experience. For example, you can take the entire rendering mechanism, shove it into your base class, and simply have your developers who churn out components define your template and your style sheet in two different APIs. Maybe in this case, create a getter that returns your CSS, and then have a render function that returns your actual HTML template. But in the end, in line 4, you simply all dump it into the shadow root and be done with it. This is really the most basic facade over the most basic technique, but this should be good enough for many people who want a cleaner developer experience, who don't like the fact that they, in the end, just shove style tags into their shadow DOM. So, this works, and if someone told me to write a whole bunch of components using the class that we see in line 9, where I simply define a template and the style sheet, I would probably accept this. This is probably okay. It's not the most beautiful, but it's definitely efficient because the base class basically doesn't exist. It's so tiny. Now, maybe you want to import some style sheets. Maybe you want to have modular CSS and you want to do something like what's highlighted here. Well, this works, but there's some possible complications that we need to talk about when we do something like importing other style sheets. So, in general, they work, but the question is, how do you structure your CSS in a way that they actually do what you want them to do? And how do you integrate them into tooling? I mean, first of all, how does this change your CSS architecture? This is one question, and I think layers are the key to making this work in a reasonable way. And then there's also the question of performance and of CSS tooling. And this is all not exactly trivial to solve. You need to put some work into this to make it work. Inline everything works best when things are simple. When questions like this don't pop up or aren't really that important because you don't have that many modules, your tooling setup isn't this complicated. But if it gets more complicated, then you need to start thinking about this. Okay, let's go through it all. First of all, how does this change your CSS architecture? I think CSS layers are what you want to use. Now, again, this is the CSS Café. I prepared this talk for yesterday for a whole bunch of PHP developers, and PHP developers didn't even know how to answer this question. Right? Which color is going to win for the P element with the class foo? You, of course, know that it's going to be line 3 because of selector specificity. Okay, this works. And you probably already know how CSS layers work, right? In this case, you create blocks of layers, write your CSS in there, and what essentially happens is that the rules get computed for each layers, and then the layers are stacked on top of each other in the order that they are declared. So in this case, we figure out a color that this element would get for the layer foo. We figure out a color that this element would get for the layer bar, but because layer bar is declared after layer foo, layer bar overrides layer foo. This is essentially how it works, and then only the order of the layers is important to determine the winner of this arrangement of CSS rules. Now, this works as expected. You can have different blocks of the layers. In this case, both instances of layer foo get merged into one layer, but the order of declaration is first foo, then bar, and then essentially an amendment to the layer foo. So in this case, bar is still going to win because bar is the last layer to be declared after foo, and the third layer foo, this gets simply merged into the first layer. And this allows you to simply declare an order of layers, like here. First comes foo, then comes bar. This is the order of declarations, and then you simply add stuff into the different layers. Okay, this is kind of obvious how it works. The order of layers counts, and inside the layers, the regular rules of CSS apply. And of course, what you would do with this is not simply create layers called foo and bar, but you would do some sort of target layering, right? You would create semantic layers. You would create layers for your browser defaults, for your theming, for your components, put them in order, and then simply add styles to the layers to, for example, reset some browser defaults, add some theming, what have you. And this would, of course, be a nice approach that you could use for your web components, because if you import something into your CSS, you can then shove it into a matching layer, which is kind of nice because then you can add layers of styles to your web component and then add a little bit of inline CSS to put the cherry on top and to make everything work just as expected. I mean, for most web components, you probably want to import general typography rules. And maybe you want to do the same sort of mechanism for resetting certain styles for each web component. And you can now just do this and import it into layers, and it all will just work as expected. But this, of course, only really works if your CSS is already structured in a way that makes use of layers. And this may or may not be the case. So if you have a project that doesn't use layers and you suddenly want to introduce web components and you want to use layers, then you have to do something, maybe restructure your entire main CSS that you had before, or maybe create some sort of parallel universe for your layered CSS. I don't know, but this is definitely a problem that needs solving. And then, of course, you might say, okay, I'm importing a whole bunch of stuff. Should I be concerned about performance? Should I be concerned about build tool integration? Maybe, probably, because maybe you want to do something to your CSS. Maybe you want to shove it through a compiler to compress it, to optimize it, fix certain things, do some transformations, what have you. And maybe, just maybe, you want to have your web page load as fast as possible. Well, in this case, it becomes, again, more complicated. I talked to Shep about this, and we came to the conclusion that performance is probably going to be kind of okay, because what you're doing with web component in this case is you have an implicit sort of code splitting going on, and you, if you need to, can add preloading, you can use the browser cache, and of course you gain something from using Shadow DOM in the first place. So maybe these intrinsic benefits offsets any performance overhead that you introduce by simply importing all of your CSS into this web component. And if you want to integrate this into build tools, then, well, I've come to the conclusion that this is probably doable with a certain amount of effort expended. This depends on the tools. Because if you take a look at this code, the highlighted bit here, where I import all of my CSS and also where I define my inline rules in line 9, this is all just a string. And a module bundler or a compiler or some sort of tool that eats my JavaScript and turns it into something more optimized doesn't necessarily understand that this is CSS code that needs to be optimized. So there's probably something that you need to do to integrate this into your toolchain. What you need to do probably depends on your toolchain. I've seen different approaches that make this work. I'm not going to go into detail right now because, again, this depends on your toolchain. I don't know what you're using. I don't know how what you can do to make this work. I've just seen several approaches to making this work. This is probably doable, but it's not a non-issue, definitely not. To come to a conclusion about inlining CSS and Shadow DOM is, well, there's certain downsides. The first downside is, it looks like the Stone Age, and that's not great. We've seen how you can paper over this using a base class. This might be acceptable, that might be good enough for you. It really depends on what you're going for. You might also argue that this is marginally inefficient because in this case, for each web component, for each instance of your web components, you essentially create a new style sheet object. There's no actually sharing between components going on with regards to the style sheets objects. Every component has its own little style sheets, or probably its own little style sheet or probably multiple style sheets, and they are not going to be shared. So this might incur some sort of a memory overhead. This is probably not the greatest problem, but still it's there. And as we've seen, this introduces some new problems because you need to tweak your toolchain to somehow be able to turn some strings in your JavaScript into optimized CSS. And how you do this will depend on your toolchain. If this is even possible, will depend on your toolchain. And of course, this works best if you tweak your CSS architecture, or if you don't have any CSS architecture. If you're just trying to create a one-off component, maybe something that's meant as a plugin for other web pages, then this might not be a problem at all. This might not be a deal breaker. So this is the cheapest solution if you actually want to use CSS in Shadow DOM. But as long as what you're doing is not simple anymore, this is going to become more and more complicated. So a simple solution for simple components, for simple setups. What if you have the exact opposite of simple? What if you do, modern web development, which means having a bunch of compilers, right? I mean, this is what web development is all about. Installing a number of tools to make things that don't work possible. Because this right here doesn't work. You cannot simply import a CSS file as a JavaScript module. Now, you might argue that this would be possible if certain JavaScript features from the future were implemented in all browsers, but still they are not. So you can write this code, it will probably not work, and if it works, it will not work in every browser. But when has this ever stopped anyone, right? You know how to solve this. Simply install something and just make it work. And I'm actually being kind of serious here, because all the tools for your modern toolchain, your webpacks, your ES builds, your rollups, your parcels, they all can make code like this work, and they can make it possible, which solves a whole bunch of problems, because this still works like a JavaScript import statement. It's going to be transformed under the hood to something entirely different, but this opens the door for your build tools to actually recognize main2CSS as a CSS file. So it's now possible for your toolchain to actually compress this, optimize this, transform this, do whatever you need to do to your CSS. And then you can get an object, styles in this case, that somehow represents the style sheet in some way, depending on your build tool. And then you can have a web component, and you can create your web component in a way that works with this representation of the style sheet that your toolchain spits out. How this is going to look will depend on your toolchain, because I don't know what you're using. This might be Webpack, this might be ES Build, this might result in styles being a string of CSS, this might result in styles being some sort of object that you somehow need to hook into your CSS. And this could be, again, dressed up to meet developer expectations, so that there's an easy way to attach the styles to the component that will then get rendered in some fashion. But this is all extremely dependent on your tooling. This will result in styles being, again, either a string, some sort of object, or something else entirely. The great thing about this is that you can do anything you want, because this is all happening at compile time, and you can create a setup as complicated as you like. You can use ES module syntax, which is great for dependency discovery and tree shaking and all this good stuff. And you can optimize your CSS at compile time, you can resolve at import, and so on and so on. This is all kind of great until you notice that what you're doing if you're using a toolchain heavy workflow is that you're using essentially something that's no longer real JavaScript, no longer real CSS, but you're using something that's an input to a compiler that then turns your code into real JavaScript and real CSS. The difference between what you're writing and what you get out of the compilers might be small, might be large, depends on your toolchain. But this is still not real native web technologies. This is something entirely different. And this might bite you as soon as your toolchain gets unusable for some reason. Maybe the project gets abandoned, maybe your company switches gears and turns to use something entirely different, and then you have a problem. The problem being that every compiler implements some sort of superset of whatever is actually in the web standards right now. So this might work for you depending on your trade-offs. And if you do modern front-end development with all the compilers and build chains and what have you, then this might be fine. But you need to keep in mind that this depends on your tooling, that this lives and dies with your toolchain. And this might be something that you're okay with, or it might be not. But just remember, if you're picking compile time solutions, you've chained yourself to your toolchain, which might be okay, but it might not be. Okay, so if that's one option to do it, toolchain, how about we create our own tools? And this is the final approach that I'm going to talk about today. This is constructible style sheets, which, if we're serious, isn't really a solution, but it's rather a tool set that you can build a solution on top of. Okay, what's constructible style sheets? Well, it's this guy right here. A JavaScript constructor function, new CSS style sheet, that allows you to create a style sheet. And this wasn't possible for the longest time. This is rather shocking how recent this feature is. There were, of course, ways to create style sheets from JavaScript, but they all involved creating an HTML style element and then picking the sheet property from this element. And even if you did this, which is really inconvenient, even if you did this, the resulting style sheets had certain disadvantages that this guy doesn't have. First of all, what you get here in line 3 is just an empty style sheet that you can populate using the replace function. Simply pass in a string, the string gets then turned into CSS rules, gets passed, and you can then use the sheet and add it to a document if you want. And you don't need an HTML style element or anything similar to do this. You can use the adopted style sheets property on the document. This is just an array that you can either replace or push new style sheets to, and then suddenly this style sheet that you just constructed applies to the document. And this is quite neat. And the best thing about it is adopted style sheets doesn't just exist on document, but it also exists on shadow rules. Aha! This is quite neat because you can now simply attach sheets directly to shadow roots and then skip the step of having style elements polluting your HTML in there. This is quite nice, but the best thing about it is these style sheets are shareable. You can have a style sheet and have it be attached to more than one shadow root or more than one document or your document and all your shadow roots. So you can have a single object taking up memory and have it work for all of your components and all of your pages. And this is quite nice. You simply need to acquire a reference to the sheet object and attach it to other shadow roots or other documents. And this is great. And it doesn't really fix our problem, right? Because this is just a way to create a style sheet and have it apply to certain elements. This is not exactly a solution to our project. I mean, this is neat. It's easy to work with. It's easy to understand, but it again only exists at runtime. How do we integrate this with our tooling? I have no idea. Someone needs to figure out something. It's great that this can be shared between multiple roots, shadow roots, and document roots, but there's also no support for import statements in there for complicated reasons that I'd rather not get into. It has to do with how style sheets are constructed, how certain security policies work, and it will probably be supported at some point in the future at import in constructed style sheets, but right now that's not the case. The main thing is that this is not a solution in and of itself, but it's an API that you can build something on top of. And if you choose to use constructed style sheets, then, you have to build something on top of this. I mean, think about it. If you want to use a style sheet in a web component or in a web page, you simply write a bunch of HTML and then it works. The browser will automatically download your CSS, will parse it into a style sheet and append it to wherever you've created this style sheet element. All of this is not going to happen automatically if you use the style sheet constructor. You have to recreate the functionality that the browser provides for you automatically if you're using anything but constructed style sheets. So you might be forced, if you want to use this, to be a little bit creative, because let's be real, the caveman approach doesn't really bring you anything. You can still keep the developer experience of the class test element from line 9 in there, and you can swap out the rendering mechanism in line 5 with something like this, using constructed style sheets, but this doesn't buy you anything. This is just a more complicated approach of creating one style sheet for every web component. There's no sharing going on. It's just more lines of code, which doesn't buy you anything. So what you probably need to do if you want to use constructed style sheets is create some sort of, central repository that manages your style sheets, and then either create style sheets that need to be created or reuse a style sheet that already exists and then distribute this across your components. So this is my implementation that I'd rather not talk about. This is just a hash function. Don't look at it too hard. And then, you could just create a central repository that maps hashes to references, to promises, to style sheets using Greek refs because of memory management. And then you can create a function load sheet that essentially hashes your style sheet, figures out if such a style sheet has already been created before, and if so, reuses it. And if it's not been created before, you don't have anything to reuse. So you create a new style sheet, put it into the repository, and then return that. And if you add a whole load of more JavaScript that I'm not going to add right now to keep the slide kind of readable, then you can make this work, actually. But you, again, have to recreate the entire browser infrastructure around loading and applying CSS style sheets, which you don't have to. There's browser infrastructure in place. You only do this to have reusable style sheets that can be shared between shadow routes and your web page. If you need this, that's neat. You can build something that does this, but you have to basically reinvent everything the browser would otherwise do automatically, which, if you go through the trouble of doing this, can result in a neat developer experience. So this is what I like to do with my constructible style sheets. I have a decorator at define that I can apply to my component classes that defines this component class with a certain HTML tag, in this case, my dash component. And this then allows me to also add styles while I'm defining my component. This can be some inline CSS. If there's more than one string, these strings are automatically generated in layers. So they are applied precisely in the order of strings that I define here. Or I can simply supply a URL. And then this URL will get downloaded, cached, interpreted as a style sheet, and reused by my decorator. And by turning it into this URL object with import meta URL as the second argument, this instructs my toolchain to actually interpret this URL as CSS and apply necessary optimizations for CSS and so on. So this is possible, this works, and if I use this in my everyday work to define components, this feels nice, but I had to write a whole bunch of infrastructure around this, and if I didn't have to do this, I would have saved myself a whole bunch of trouble. And now this is something that I have to care about, that I need to maintain, that I have to think about whether or not I do it in the most performant way possible. So this is great if you want to create your own style sheet handling, if this is exactly what you wanted to do. But if you don't want to recreate half of your browser, then maybe this is not exactly a solution for you. This, I would say, is something that can help you if you really want to create something from scratch. If you have your brand new design for your application or for your pattern library or whatever you're creating, then this is quite neat because this is just the tools that you need. But, this presupposes that you actually want to build something as complicated as what I've just described. So this is not a solution by itself, but something that you have to build on top of. You have to work around the non-existent support for add import, which may not be a problem if you somehow manage to shoehorn tooling support into your solution that, again, you have to build yourself. So then maybe that doesn't matter for you. And it's not always, again, trivial to integrate this with your existing toolchain. Because, again, you have bare strings that may be URLs to CSS files, or that may be CSS in and of themselves. How do you tell your module bundler to process bare strings in JavaScript as CSS? Well, there's ways to do it, but this is still work that needs to be done. So maybe all of this work is just what you need, and you want to do this, and you have a plan in mind how you can build something on top of this, but maybe you need something different, and then probably constructible style sheets are not what you need. So this is all my techniques And as we've seen, and as we will see in our final conclusion, there's a whole bunch of trade-offs and downsides to each and every approach. And I think this is quite fitting for Shadow DOM, because Shadow DOM, as I said in the beginning, is just a bunch of trade-offs and compromises. And why shouldn't this also extend to CSS that we want to use with Shadow DOM? So if there's anything that we did learn, then it's probably that Shadow DOM comes with built-in compromises that will also affect your CSS. You cannot simply write old school CSS and have it work just before, and also combine it with the Shadow DOM. You need to change your CSS architecture in some way, at least if you use Shadow DOM. Again, option 0 is always to skip Shadow DOM. There's different approaches that you can follow, and what approach you want to follow will probably depend on the goals that you're pursuing, and it will also depend on what kind of constraints you have with regards to tooling and so on. So, to turn this into a final giant table, if your goal is to simply get your CSS under control, which again, I don't hope that this is what you want to do, then you could always just write better CSS. I think this is an option if you actually try. Many enterprise web developers don't want to try. That's their business. I think if you can write proper CSS and this is all you want to do, then skip Shadow DOM. All the complications aren't really worth it. If you want to ship universal cross-stack components that are really not part of something bigger, but more like plugins for specific problems, then you can simply dump CSS in style. Then you have zero dependencies, you have universal cross-stack robust components, and you don't need to care about optimization and toolchain integration that much, because it's probably just going to be a tiny little bit of CSS. There's not much sharing necessary. So the simplest solution works best in this case. If your workflow is typical modern web development with extensive amounts of tooling, then the cheapest way to do style sharing is probably leaning into your tooling. Simply have an import statement that imports CSS files and have Webpack or ESBuild or whatever figure out how to make this available to a certain shadow root and simply be done with this. This is the path of least resistance if your toolchain already exists and if you want to lean into compiling everything. Why not use all the tools that you're using anyway? Constructible style sheets are probably best suited for the grand new design. If you want to create your own custom web component framework, if you want to create a pattern library from scratch, if you really want to design everything from scratch and really benefit from some sort of basis of framework of library that you're creating, then constructible style sheets are just the tools that you need to build something yourselves. This is the most flexible approach, but again, this requires you to build something yourself, which you maybe don't want to do. And the final point in this table, and something that I have neglected to mention thus far, if you use something that already comes with a solution, like for example, a web component framework, like Lit, you're using a framework, you are tethered to this framework's fate anyway, so simply do what the framework does, stop thinking about it, and simply follow the path of least resistance. Don't make your life harder than necessary. You can make your life harder than necessary if you want to use Shadow DOM in your web components, which you totally can do, and you have probably now seen that there's a bunch of different approaches to getting this to work with CSS. There's a bunch of downsides, there's a bunch of upsides to each approach, and it really depends on what you're trying to do and how your tool chain looks. This is at least what I found in my research, and if you have any other constraints or other ideas for handling style sharing with web components, I'd be thrilled to hear from you. But for this presentation, that's it for me. Remember to hire me to come to your company and talk about other web standards, about JavaScript, about web components in general, or about style sharing some more. Thank you for being here, and now on to questions and answers.